Now next to our question is that how can you find out the VT, which means that voltage, Thevenin voltage and resistance. How can you find out two value? That's the questions. Here is a summary. So we can go over step by step. So two source is essential. Two element is essential for creating Thevenin or Norton equivalent circuit now. So now here, this Thevenin voltage is open circuit voltage. One terminal we say that A terminal, and the other terminal we say that that is B terminal. Then this open circuit voltage VAO VOC open circuit voltage equal VAB, and this voltage equal to Thevenin VT, exact same. Then how can you calculate the VOC open circuit voltage? Go back to original circuit, and then we can calculate the VOC by using node voltage analysis or mesh current analysis. Node voltage analysis, you can determine node and node voltage V1 and V2, V3, something like that. And this is reference voltage, so which means the ground voltage 0. And then find out the you can set up the KVL equation or KCL equations with the Ohm's format, and then you can find out the V open circuit voltage, VAB or VOC. Okay, or you can use mesh current method. So here is one loop 1, and the other loop we may use another loop on here, something like that. So based on the loop, mesh current, so current 1, current 2, and current 3, something like that, and then you can calculate the current via KCL equation or KVL equations. So somehow if you find out the open circuit voltage VAB from the original circuit, then that is the Thevenin voltage. Is correct? Yeah. So you can calculate the open circuit voltage by using the node voltage analysis or mesh current analysis. So one component we can find out the value. And the next, this is an open circuit, so we don't know about the current because this is open circuit, so current does not flow in the circuit. However, in order to find out the current, then we can make a short circuit. We can connect two terminals with short circuit, just jump wire connected, just wire connections. Then what happens? So this is a kind of loop, and one voltage source and one resistance. So we can apply Ohm's law. So short circuit current can be calculated by V over R T. Is correct? Yeah. Intentionally we connect these two nodes, and then current will flow. So in this scenario, currents can be calculated by Ohm's law, right? So in that idea, first draw the short circuit, which means that there is no resistance, so the current flow without any energy drop or voltage drop. So now here way is that you can connect it short circuit like that. So then current will flow. Let's do once again. Okay, so now original circuits, you can connect it to terminal with the short circuit. So same thing, connected it A and B terminal, and then current coming in through the channel, and then they go it, so they will split into the one-way short circuit or going down to the resistor. So currents, what do you think? Current will going down through the resistor, or they will going down, they will go to the short circuit? Current will go to the short circuit only because there is no resistance. So example, so current coming in, and there is branch, so they will choose. If similar resistance on the two branch, then they will current will divide. However, there is current and there is resistance, and there is resistance and there is no resistance on the other circuit. The current will flow only one way. Current will flow into short circuit only because there is resistance. It's not zero, so current only flow in these directions, which means that current across the resistance will be zero. No current, only they will flow in these directions. So intentionally you can draw the short circuit, and then this one's kinds of nothing, no current, and then you can recalculate the current on here. So that's the one of the method to find out short circuit current. If you find out the short circuit current and voltage, then you can calculate remaining value R by using the Ohm's law. So which means that VT over ISC. Okay, and the next, another method is that zeroing method, zero independent source. So this way is that to find out the RT, the Thevenin resistance. First, number one indicates find out the VT, the Thevenin voltage. Number two, and we are talking about the current in order to define the current. And now if we cannot find out the current, then we need to find out the resistance. So then one easy way is that zero independent source. If circuit contains only independent source, that's one conditions it should be met. Circuit should be met. Circuit contains only independent source. Let's take one example on here. So now this circuit was given, and this circuit has an open terminal A and B. And now we want to calculate the open circuit voltage, positive and negative. And also we want to know about the Thevenin voltage, Thevenin resistance. So in this case, we can apply zeroing method. So independent current source and independent voltage source on here. So which means that we can remove it. So in zeroing voltage source, that is a short circuit. So now remove the voltage and then they become a independent source. So one of the reasons is that the voltage source, I already bring the example. So here voltage inside and voltage source, positive and negative, and resistance, but inside are almost zero, which means that they go to zero. Ideally they go to zero, so inside there is no resistance, current flow, so which means that voltage source is kind of short circuit. Voltage source, zeroing voltage source, replace with the short circuit. Okay, and next, current source. Current source I already drew before, like a battery. As you know, inside there is circuits, closed loop, current source, and this resistance, resistance go to infinity. Okay, so current flows but infinity, so when they connect it to the other circuit they start flow. Alright, so now this is resistance is infinity, so in this case current cannot flow. So let's assume this is the kinds of open circuits because of the resistance go to infinity in current source. This makes sense. Now remaining things draw here. So one resistance and the other one's resistance, and this one is open source, open circuit, and the voltage source become a short circuit. So now seems like okay, so two resistance connected in parallel. Okay, so resistance, they are connected in parallel. So by using combination of resistance in parallel, we can calculate R equivalent, which means that 1 over R1 plus 1 over R2, that is 1 over R equivalent. So which means that this R equivalent is the Thevenin equivalent resistance. So based on the zeroing method, you can calculate the Thevenin resistance. Okay, and the next, so now here we know we can calculate the VT, and we can calculate the current or RT, and then we can draw the Thevenin and the Norton equivalent circuits. Right? Okay.